Learning FDP Faculty Development Program on 3D Printing and Design organized by Lord's Institute of Engineering and Technology in association with Center of Product Design and Development and Additive Manufacturing, Osmania University, Hyderabad. So today we have session on biomedical applications of 3D printing by Dr. L. Sivarama Krishna, Associate Professor, University College of Engineering, Osmania University, Hyderabad. So our resource person will be soon here. So till then, I request all the participants to join as soon as possible. Good afternoon, sir.
Good afternoon.
How are you, sir?
Fine, fine, sir.
Fine,
How are
sir.
you?
I'm fine too, sir.
Participant
So,
joined.
yes, sir. Some of the participants are still joining. This is the post-noon session, so after lunch they will
Let us
join.
wait for 5 minutes.
Sure, sir. Sure. We will wait, sir. So, I once again welcome Dr. L. Sivarama Krishna, Associate Professor, UCE, Osmania University, Hyderabad. So, he will going to be delivering the session on biomedical applications, innovative applications, and 3D printing. So, I request Ms. Simena Devi to introduce and say few words about our speaker. Over to Ms. Simena Devi.
Dr. L. Shivaramakrishna garu, Professor of Department of Mechanical Engineering, University College of Engineering from Osmania University. He completed his BTech from Mechanical Engineering in the year 1991 from Kakatiya University, Kids, Warangal. He completed his MTech in SIM, Regional Engineering College, presently known as NIT Warangal. He has the respect to PhD Mechanical Engineering January in the year 2010 from JNTU, Hyderabad. He worked as a research assistant from 1993 to 94 in Department of Mechanical Engineering, RAC, Warangal. He worked as a lecturer from 1994 to 2002 from Department of Mechanical Engineering, BMR Polytechnic, Warangal. Sir also worked as associate professor and assistant professor from 2002 to 2007, Department of Mechanical Engineering, KITS, Karimnagar. Worked as a assistant professor from 2007 to 2015 from Department of Mechanical Engineering, University College of Engineering, Osmania University. Working as assistant professor from 2015 to till date, Department of Mechanical Engineering, University College of Engineering, Osmania University. His areas of research interest are additive manufacturing, 3D printing, CAD CAM, SIM. He also has guided number of PhDs. Currently, he is supervising 9 PhD supervisor since 2012, and he also guided number of ME students, and 80 are done and 10 are ongoing. He also visited Florida International University, and he also visited Teesside University, Newcastle, UK during the 2009. So I would like to welcome you for this session, sir.
Thank you. So, thank you, Junaid, and the management of the Lord's College, especially Professor Shiv Prasad sir, and other head of the department, other people in the Lord's College, and also the management. I think this is the second time I'm delivering a lecture in Lord's College. I think last time we delivered in the month of September.
Sure, sir.
Uh,
Sure.
yeah, thank you very much for the opportunity given to me for the little bit of knowledge I gained during the 10 years in working in the area of 3D printing. And I hope after lunch I'll make you all not to sleep. That is my challenge, right?
Sure, sir.
Because usually after lunch, and all of you will be in especially in online mode.
Yes,
Most
sir.
of
Yes.
you will not be seeing each other. So my challenge will be not only to deliver the lecture and deliver the contents to you on 3D printing, but at the same time I want to make you to be live and listen to it. That's why I put lot of videos here so that I will not make you to sleep.
Sure,
So
sir.
it's
Sure.
going to be entertainment session, and that the title of my lecture itself is 3D printing and innovative applications. So the applications which you never thought that an engineer can work there also. You will be getting jobs in future there. I hope on my screen you are seeing a lot of pictures here. Usually I don't like my slide to be boring with
Yes,
only
sir.
blank slide, and I want to put so many things here. What you see on the left side, I am going to talk some little bit of technologies at the beginning, 3D printing and how do you classify 3D printing, and what are the various technologies you have in 3D printing classification. Apart from that, I am going to showcase you some applications which are you never thought. Like for example, here at the bottom left side, you are seeing FDM technology, a laminated object manufacturing technology. And are you able to see my cursor? I hope I can do annotation also, right?
Yes, sir.
Annotate.
Visible. Yes, sir.
Yeah, yeah. I can take. I think I can use a pointer. I think. Yeah, this is what a FDM printer here. So it can be used for making a product using a wire, and you can see a laminated object manufacturing system where using a sheet metal you can produce a component. At the same time, you can use a powdered also, which where you expose the powder to a laser beam, and it sinters or it melts it and make the final product. These are some of the different types of technologies you have. At the bottom, you are seeing a particular kind of helmet-like thing, so which is nothing but a suit or mask which was made for a film called Iron Man. The Iron Man suit, the entire thing is fabricated using 3D printing. So I want to tell you is 3D printing is there in entertainment industry, movie making also. Some of you love movie making. Please think about acquiring this skill. Not only future, already presently most of the movies are using this technology. In future, this will be a default in many movie making big budget movies. You can see this type of things will be used. So this is made using 3D print technology. Now, at the bottom also you can see a what you call our arts college, iconic Osmania City Arts College building, the model of which I created using 3D printing technology. Our own students it and created a replica of the same thing without missing any intricacies. So using 3D printing, we are able to produce. So you can use 3D printing to produce a model of a big structure which you want to construct in future. Before that, to have a physical idea or to have a physical model look around it before you make it. So for having an idea, understanding and a concept for that you can use 3D printing in civil engineering also. Not only this, now in civil engineering you are actually constructing the entire building using 3D print technology. Recently, I hope you might have seen the news. LG is using 3D printing for has created one house in I think in India. I think in Hyderabad only. They are planning to construct such type of houses to meet the government of India scheme the housing for all. So the 3D printers in the future will be used for constructing your homes also very fast and with good finish everything. At the other side, at the bottom, you are able to see a particular type of jewelry, which is very intricate in shape. Imagine to produce such type of thing using a conventional method is a very difficult task, but using 3D printing is a very simple task. So, jewelry industry also adopted 3D printing a lot. And you can see at the bottom, I hope most of you in the pandemic time, you want to love to, you are a foodie, you want to go to different places and have different types of dishes for you, but because uh, you are uh, uh, you are feared of going out due to pandemic and having a nice lunch like earlier days, going to a home and going to a restaurant having that is now it is slowly picking up, but no, still we feel fear to go there and eat. So instead of that, I want to have my own food. I can have a food 3D printing food 3D printer which can print as per your desired design model of your paste you want to have with a required combination of nutrients, etc. You can print it. This is what NASA is now developing a food 3D. Already food 3D printers are available outside with Harsley and big chocolate making companies. They are making these chocolates using these 3D printers without any much human involvement, because in this pandemic now you very where you have less human touch, then most of the time automation works out and it help you a lot in avoiding that kind of what you call or infectious things not coming into your food. So this type of 3D printer now NASA is developing to send it to Mars, so that when the NASA is planning to send human beings to Mars, astronauts to Mars in another couple of 4 to 5 years. So where the astronauts will stay on the Mars for another 2 years, etc. At that time they would like to have food. So how to because they want to yeah, you astronauts when they stay 2 years, they require food to live now. So how to make food for them? So they are now making 3D printers for making the food. That type of video clipping I am going to show it to you. So application of 3D printing food industry, very exciting area where you can work out. And you can also see at the bottom, you are able to see a particular type of antenna. This is called horn antenna. An electronic guys knows the horn antenna. And this in electronics now for communication, this antenna is used a lot. Earlier they used to make using a sheet metal. Now they are making this with the help of a 3D printer, and on which you are going to have a what you call a, metal coating, so that your communication signals will reach better. So using electronic industry also embrace 3D printing technology a lot, and it is using it to a maximum potential. So application of 3D printing in a sports industry like a shoe making industry, where the athletics shoes are made using 3D printing technology. This is a Reebok shoes called liquid shoes, which is made using 3D printing technology. So you can see the outer sole of the shoes, which is made up of butler kind of structure, and this entire thing is produced using 3D printing, so that the athletic will have a good grip on it, and also when you try to run, this will have very good bouncing effect on it. So it makes the sprinter to feel as if you're doing a 3D walk like that, right? That's how it happens here. So like this, many big shoe companies like Adidas, Nike, mm, all of them started adopting this technology. That's why those shoes are costlier than the conventional shoes. Earlier, the shoes are made with mold. Now you can see at the top a Butler SUVs, a space SUV vehicle, which is now made by NASA to send to Mars, and where the two astronauts will be sent on this. So reaching Mars takes 1 year. So lifting such a heavy vehicle from here, from Earth to Mars, is not a simple task. So in that, the definite challenge will be how to reduce the weight of the vehicle without compromising on its safety. So where 3D printing is used a lot, when 70 FDM parts are made using 3D print technology, and they produce these parts and fix it to this astronaut. That video I am going to show it to you. Similarly, at the top you are seeing a satellite, like this is called CubeSat satellite, which we made in our college, and using our 3D printing technology, FDM technology. So this is a CubeSat satellite mainly used for special communication purpose, like identifying the minerals, identifying the enemy territory, or getting the weather forecast, specific weather forecast, etc., where you can use it. So such type of small satellites will be launched by ISRO. When they launch 50 to 100 satellites, most of them will be a CubeSats doing some specific purpose, right? So I'm going to present all these things in my talk. That's why I'm calling innovative applications of 3D printing, right? So let me proceed further. So before I go ahead, I know most of you might be knowing now. My director will be also coming and presenting. We have excellent center of 3D printing called Center for Product Design Development IT Manufacturing, Osmania University, which is a state-of-the-art 3D printing center excellence of 3D printing with 6 crores we established. It has got latest technologies like selective laser melting metal 3D printing, SLA selective laser sintering, SLA DLP, stereolithography apparatus and direct light projection system, Polyjet, Ultimaker S5 Pro FDM and Artec 3D scanner. So using this, you can do any work. You have different variety. You have a metal 3D printer, you have a powder bed fusion technology, you have a liquid based technology, and you have a wireframe technology, you have a scanner, everything. So this center will cater to so many people. The idea is to give interns to BE students. BE students can do their internship. ME Tech students can use this for their project work or can do internship. Or PhD scholars can also utilize this facility on a minimum chargeable basis. Apart from this, we also do consultants for DMRL, DRL, other institutions, and we do work with hospitals around Hyderabad for planning, pre-planning surgery of complex operations, etc., which I will be presenting in my next lecture. This is headed by Professor Sira Venkatesh, who is going to speak the next sessions, and I am the joint director for the center. So this is only brief introduction about our center, right? So let me start with what is the meaning of what is the definition for 3D printing. There are two prominent definitions, one given by Terry Wooler and other one by ASTM International. So according to Terry Wooler, 3D printing or additive manufacturing is the technology that produces models and prototype parts from 3D CAD model data, CT and MRI scan data, and model data created from 3D object digitizing system. So you create a CAD model. Initial step of any 3D print technology to manufacture, you have to first create the model. That model you can create from scratch, either from drawing using your software tools like your Creo or your SolidWorks or AutoCAD, or you can use like Unigraphics. All those things you can start from scratch and create a 3D object, or already existing object is there, you can scan the existing object using a scanner, 3D digitizing systems, and you can build up the CAD model. Or if you are having a biomedical thing, you can directly take a CT or MRI scan, and from that you can develop the CAD model. So I hope morning session is taken by my student, Mr. Manmadachari, on biomedical modeling. Is it done, sir? Morning?
Yes, sir. Yes, sir.
Yeah,
Yes,
yeah.
sir.
So by this time how to do all those things. So this is what it starts with. And additive manufacturing, new process of joining metals to make objects from 3D model data, usually layer by layer. It is a Now we generally confuse what is the difference. 3D printing, additive manufacturing, both are same. Additive manufacturing is the technical name given by ASTM. So technically in our research everywhere you use ASTM, but commercially it is more popular in the name 3D printing. So the thing is, you construct the object from the CAD model by adding one layer or another layer, whereas in subtractive like CNC, other machining process, you remove the material. So that's why additive manufacturing is also known as positive manufacturing. Right? So here the amount of material loss is less when compared to the conventional manufacturing process. So what are the basic steps involved in any additive manufacturing is you have 8 steps. First is the creating the CAD model, which is very important because the CAD model is not created properly, the end product will be a failure. It is like garbage in, garbage out. So you should take proper clearances, everything, then you have to create a CAD model. Once you create a CAD model, you have to convert into a STL file. So STL file means conversion to number of triangles, triangulations you have to do. And once you do the STL file, that you have to slice it into number of layers. So because you are adding one layer or another layer, so for example, your cup is having, so let us say 10 centimeters height or 5 centimeters height. Each layer is 0.1 mm. So you'll have 50 layers you have here. So that 50 layers you have to slice it. Then when you convert into STL file, you will definitely get some errors because you are having curved one, you are converting a triangle. Triangle is basically a straight line, three lines joined together. So that gap you have to remove those things. Once you remove the errors, then you have to send that one to the machine and to the sort computer which is attached to the machine, where you do the setting of the parameters, like how much layer thickness you want to use for building the part, what is the orientation which you have to build the part, what is the infill that you have to take. That means whether you want a full solid part or a semi-solid, or what is that percentage, or what is the hatch pattern. So many other parameters that you should take care when you before you send it to the machine. Once you do it, then you have to start building. You have to start building the part in the machine. Then you have to do remove the part, and then you have to do post processing. That is, you use air blasting or sand blasting, or you can also use what you call it as a curing process. If it is a liquid based one, you have to cure in a oven, and finally the part should be used. So these are the basic steps involved in any 3D printing technology. So how do you classify 3D printing? You generally classify it with liquid based system, solid based system, and powder based system. Liquid based, you either go for molten or a polymerizable. That means molten means you take a wire, you extrude the wire and heat it, then it becomes fused, and that is called material extrusion process. Example of that is FDM, fused deposition modeling. Whereas in the polymerizable, you will take a liquid resin, expose that resin to a high intensity light like a laser beam or UV light. So automatically the resin, which in the form of monomers, after taking light, becomes a polymer, and the layer becomes hardened. So that you have two things: polymerization technique, and other one material jetting technique. In material jetting technique, you spray a liquid through a fine nozzles like your inkjet head nozzles. You spray it, and finally you get the build apart. So this example of wet polymerization is SLA, DLP, and all those technologies. Stereolithography apparatus, first 3D printing technology that was developed by Chuck Hull, and they now got with SLA, DLP, direct light projection. You, instead of using a laser, they use a light projection system, UV light from the bottom. That what we have in our center, SLA, DLP. And you have material jetting technology, where you use a inkjet type nozzles, very fine nozzles. You spray the liquid and you get the part build up. And you have solid base, you have bonded objects. You take a sheet metal and try to bond one layer to the other layer, one sheet metal to other sheet metal, and you build up the part here. So that's what you have, solid base technology. Whereas in the powder base, again you have two things: melting and binding. In melting, you melt the powder, and or you sinter the powder. That is powder bed fusion technology. You spread the powder on a bed, and you try to sinter it, and or you try to melt it full. So that's sintering is SLS, selective laser sintering, or DMLS, direct metal laser sintering, or you may use SLM, selective laser melting. So melting process, right? There are different technologies here. We'll discuss each one of them in detail. Direct energy deposition, where you take a powder and try to impinge on with a laser beam directly. When the powder comes directly, it will be hit by this direct by the high intensity light. that becomes a molten metal and you build a part. That is a lens, laser engineering in net shaping comes under that. And in binding, you have binder jetting. That is, you take powder, that powder you spray it with a adhesive resin, adhesive and that like inkjet nozzles, you spray that one. So that adhesive attaches one particle or other particle and you build the part. So that is powder bed technology. So you have, these are the different types of technology you have here. So 3D printing, Jet Corporation 3D printing comes under this binder jetting process. Let us see vat photopolymerization. So it's a process by which a liquid photopolymer in a vat is selectively cured by light activated polymerization. It is patented by Chuck Hull in 1984, and they developed he founded the company called 3D Systems, which is very popular. And a liquid photo curable, it's a basically US based company, resin, thermoset metals, and accuracy is up to plus or minus 0.2%. And it requires support structures for building the part, because of course this is a liquid, so require a support structure to build these parts. So what is the phenomenon in this SLA technology is you have all this liquid in the form of monomers. So when you send high intensity, like because Planck's constant frequency, it will start exciting the photoinitiator. Finally, you have a chain initiation, chain propagation, which will leads to forming a polymer. So here the layer gets hardened up. It's like, for example, you take a milk in a container and it is initial in the form of liquid. You start heating it, boiling it. When you send the heat energy to the top layer, you get hardened one, because that monomer taking this energy start attracting with another monomer and becomes a polymer like structure. Like this here also, when you expose that liquid to this high intensity light, it will become hardened. So that is a phenomenon used in this SLA technology. In SLA, you use laser, carbon dioxide laser, whereas in SLA DLP use a UV light projection system. So both are photosensitive resins you use in this case. So what happens here, you put this, for example, this platform, on this platform you are having you have to build a part. So the platform will be first at the top position, and according to the geometry of the shape you model, this is already sliced and stored in your 3D machine. So according to this each layer cross section, the laser beam will move in the XY direction. So that portion of the resin gets exposed to the light, it becomes hardened. Once that particular layer gets hardened, the platform will move down Y direction. So laser beam will move in the X direction, platform will move in the Z direction. Like this, once this gets attached, then next this will go to below. According to layer thickness, this will go to the next below that one. And again, the laser beam will move in the X direction. It starts adhering to the previous layer. Like this, you start building the part. So only thing is, when you have O-ranks system, O-ranks in your product, some extra projections, so you require a separate support structures to this. And every time this liquid will be equally spread on it by a recoater blade. So these are the things you have basically in a vat photopolymerization system. So it is in a SLA you have laser from here, but in the case of DLP you have the projection, light projection from the bottom you come here. So these are the two ways in which you have. But both the cases, the idea is when you expose the photosensitive resin to high intensity light, it gets hardened, right? So let us see this video. Sir, when the video starts, let me ask whether you are able to hear the audio or not. Please tell me, sir.
Sure, sir. We are able to hear you.
Stereolithography
Are
is
able
a
to hear
process
the?
that translates CAD designs into solid.
Are able to hear, sir?
Yes, sir. Yes, sir.
Stereolithography
Right.
Your video is audible,
is a
sir.
process that translates CAD designs into solid objects through a combination of laser, photochemistry, and software technologies.
This
With 3D system
These the
stereolithography,
old 3D printing SLF systems that was originally developed. But now what you are going to see in I think that is there in your demo also, you are going to see SLA DLP where the light will come from the bottom, that we have in our center. So it's a very unique machine you have in our center. That is now somewhat different from this SLA technology.
apparatus, or SLA, CAD data of the product design is first sliced into very thin cross sections. A laser beam of ultraviolet light is then focused onto the surface of a vat of liquid photopolymer. The laser traces the cross-section of the part, turning a thin layer of the liquid plastic to solid. The cross-section is lowered and recoated with liquid photopolymer, and the laser traces the next slice on top of the previous one. The process continues, layer by layer, until the part is complete. Unattended, the SLA works around the clock. Without tooling, machining, or cutting, a three-dimensional
This is what you have to do planning here. See, is producing 4 parts at a time. So this is the stacking you have to do before you start building the part in the software itself. Right.
part is built in a matter of hours.
So this is how SLA technology, wide photopolymerization works. Next, I'm not going to discuss. There are so many technologies again, wide photo like solid ground curing, so many things. We are not going because we have to spend a lot of time on that. Just each technology I'm going to each classification I'm going to discuss one technology. So now material extrusion technology. This is a in which material is selectively dispensed through a nozzle or orifice. It's basically like an your metal forming an extrusion process where you have a nozzle. Through the nozzle you send a wire, and when the wire comes to the nozzles, it gets extruded, gets heated up, so that becomes fused, and that becomes a molten state, and it will come like drops and fall onto the bed. So blood will move down and the nozzle will be moving in the xy direction. So this is how it happens. Robotically guided plastic extrusion, thermoplastic material is used, low temperature, high temperature metals, accuracy is up to plus or minus 0.005, and water soluble or wax patterns are used. This is how you have two nozzles. You have dual extrusion or you may have a single extrusion technology. You have dual extrusion. One extruder can be used for support materials. Other extrusion can be used for making sending the direct material. Right. So this is how your parts can be built. This will be moving in the extrusion. It will be moving in the XY direction. The platform will move in the Z direction. This is how the part will build it up. Let us see this with this video.
Fused deposition modeling, or FDM, is a layer additive manufacturing process that uses production-grade thermoplastic materials to produce both prototype and end-use parts. This technology is known to accurately produce feature details and has an excellent strength-to-weight ratio. FDM is ideal for concept models, functional prototypes, manufacturing aids, and low-volume end-use parts. The FDM process begins by slicing 3D CAD data into layers. The data is then transferred to a machine, which constructs the part layer by layer upon a build platform.
So you can see, sorry.
Manufacturing process that uses production-grade thermoplastic materials to produce both prototype and end-use parts. This technology is known to accurately produce feature details and has an excellent strength-to-weight ratio. FDM is ideal for concept models, functional prototypes, manufacturing aids, and low-volume end-use parts. The FDM process begins by slicing 3D CAD data into layers. The data is then transferred.
So you can see there are two spools of wire. One is for making the actual model, other is for a support one. So you have two extrusion nozzles here. Now sometimes now you put the same material, you can use it for support structure also. So you can put two different materials here. So that is the advantage of this.
To a machine, which constructs the part layer by layer upon a build platform. Thin thread-like spools of thermoplastic and support material are used to create each cross-section of the part. Similar to a hot melt glue gun, uncoiled material is slowly extruded through dual heated nozzles. The extrusion nozzles precisely lay down both support and thermoplastic material upon the preceding layers. The extrusion nozzle continues to move in a horizontal XY plane while the build platform moves down, building the part layer by layer. The finished part is removed from the build platform and cleaned of its
white
support
one is
material.
the support and the black one is the final part that you want to make.
Raw
This is the
FDM
post
parts
process you
have
are doing
visible layer
here.
lines. However, service providers such as Solid Concepts offer multiple finishing options to create
So for a
smooth,
smooth
even
finish, you
surface
can put
parts,
in a
including hand sanding,
special chemical
assembly,
and
and
get
cosmetic
the
paint.
finished shape.
Since FDM parts are constructed with production-grade thermoplastics, including ABS, polycarbonate, and Ultem, they are both functional and durable. FDM is utilized in a number of industries, including aerospace, automotive, industrial, commercial, and medical.
Yeah, this is the next metal jetting machine. So here you send inkjet print heads you have, you deposit droplets of material and build the part here. So print heads and support heads combines high precision milling, no ash content, wax patterns for metal casting, jewelry, dental and medical other things you can make. And you can have a high level of precision also, plus or minus 0.001 mm you can have here. So here you can see the two printer nozzles, and you have this reservoir through which the liquid material will be sent, and you will be depositing that on the platform and build the part here. And whenever you want to have a small milling head, so that you will have finishing also. The thing is, you will what advantage you have here is very fine nozzles are there, so you have very good surface finish that you get here. And also the part or advantage, you have a transparent parts also you can produce in polyjet. It is having higher accuracy than SLA technology. Definitely it is costlier than SLA technology. This is from statistics. We have this in our center polyjet. This will be a demo, I think, is going to given by Professor Siva in his lecture on how polyjet works with a part, how we are going to produce, right? So let us see how this, with this video, let us understand how polyjet functions. Simple basic principle.
PolyJet is a 3D printing method that makes beautiful, precise models in a huge variety of materials and colors. It works like an inkjet printer, but instead of jetting drops of ink, PolyJet 3D printers jet tiny droplets of liquid plastic. A UV light instantly cures the plastic, solidifying it. And so, layer by layer, complex models take shape. The most advanced PolyJet systems can build multi-material parts, soft, rigid, clear, and colorful. You can even adjust material properties like heat resistance and durability. The same technology that makes gorgeous prototypes also makes precise manufacturing tools. Designers can predict future needs and serve them now. Manufacturers deliver better products faster and with less waste. Researchers have new methods of saving lives. PolyJet is reshaping
Especially in
industries like
RoboCop
film,
movie, the
fashion,
entire
and
suit was
medicine.
made using polyjet
It's
technology.
helping people with great ideas improve the future. What's next?
So the other one is a binder jetting technology, where you are going to, is a process by which a liquid bonding agent is selectively deposited through inkjet print head nozzle. So just don't get confused. Earlier case, there is no binder metal. The liquid itself is jetted through it, metal is jetted, and you are going to build the part is sent. Whereas in the binder jetting, you are having a you are going to send a binder, a binder, and you are going to deposit on powder, right? So here the input material in the form of powder, on which you are going to spray binding metal, so that one particle starts attaching to another particle, and adhering to other particles, build up the final part. So here the advantage, you have a colored parts you can produce here, which in very less cases you can have this. So the advantage of binder jetting machine is it is cheaper, and it can be put in anywhere like an office desktop printer, and you can have a what you call colored prints, and you can understand very easily for prototyping, for studying purpose, etc. But its strength is not as good as the earlier one. Finish is also not as good as the polyjet and other technologies, but it can be used for concept models and other applications for understanding everything. For example, you are want to build, you want to make a building, you can directly show with colored ones, so it looks very beautiful. Or you want to explain to your student how will the different parts of a particular machine part functions, and you can make a sectional view and make it with a cheaper rate, you can make it, right? So no support structures are also required here. So here again, you have this platform will move in the XY direction, and the this build platform will move down. This particular inkjet print head will move in the XY direction. The build platform will move down, and you have a what you call a binder droplets, which will fall on this powder. It will start adhering one particle to other particle. You get the final part build up, right? So this is a binder jetting technology. Let us see this video how Z Corporation used this technology for making various parts.
Now, create full-color 3D models more quickly, easily, and affordably than ever, right in your office. Introducing the Z Printer 450. The Z Printer 450 brings CAD files to life as realistic physical 3D models with precise detail and brilliant color, and does so 5 to 10 times faster than other systems at less than half the cost. Dramatically present the proposed look, feel, and style of product designs and prototypes. Vividly display architectural visions, and better communicate 3D information in education, healthcare, and the arts, all in ways that electronic displays cannot. The first automated 3D printer, the Z Printer 450 is remarkably easy to use and very office-friendly with clean, quiet operation. And it's from Z Corporation, the industry leader in color 3D printing technology. The Z Printer 450 is for those seeking high-quality color 3D models, plus the convenience of an in-house printer to build those models anytime, anywhere. The uniquely automated Z Printer 450 simplifies the entire 3D printing process. Self-contained and self-monitoring, it manages nearly every aspect of printing, cutting user interaction time by 40%. Simply import your 3D data file into our ZPrint software, position as desired,
Now you have to do
and follow the
orientation
prompts.
and building everything.
The
You have to
system
set before you
automatically
build.
checks supplies and printer readiness, ensuring you always have the right amount of materials to complete the job. If supplies need replenishment, it's as easy as inserting a 1-liter binder cartridge, connecting a powder canister for automatic loading, or snapping in a new printhead.
So this is where you get color
When ready,
coming
click
up.
3D print and watch your 3D model emerge from the bottom up, one cross-section at a time, in 450 dpi resolution. Advanced inkjet technology builds models 5 to 10 times faster than other rapid prototyping systems, so you get your model in hours, not days. When printing is complete, a vacuum and motion system automatically removes up to 80% of loose powder and recycles it for future use. Removing the remaining powder is just as easy, using lightly compressed air in an enclosed chamber that
This is the
vacuums away
post-process you
particles
are
as you
doing
go.
here.
Plus, with no
If you
physical
want to have
support
better
structures
finish, you can
attached to
dip
the
in a
model,
particular
like
chemical
other
to get
printers,
better finish.
you can say goodbye to dangerous scraping tools and chemical baths. Every 3D model emerges clean and ready for finishing with one of 3 processes that vary surface finish to match any application. Choose a quick dip in Z-Bond sealant followed by a short drying period. Get the same effect by dripping Z-Bond over the model, or lightly brush with Z-Max Infiltrant for a strong, brilliant color finish. Regardless of which you choose, you get a smooth, vivid color model that lasts, and you get it fast. In fact, from start to finish, this model was printed, depowdered, and finished in under 4 hours. Best of all, the
Very
Z Printer
easy.
450
See
is
how you can
incredibly
print such a
office-friendly.
complex part
The
within
small
4 hours,
footprint, negative
and you
pressure
can
dust
put in an
control,
office
noise
also very
suppression,
easily.
and zero
There
liquid
is no
waste.
noise
It's
also
just like
in
any
using
other
this
printer in
printer.
your
Less
office.
energy consumes
Everyone
everything.
can afford to
But
create 3D
not
concept
a
models,
functional one.
functional product prototypes,
You
architectural
make
models, and
some
more,
models,
and do it
etc.
all in-house.
Study purpose.
It's fast, it's color, it's easy to use, and it's available at a breakthrough low price.
Similarly, sheet lamination machining. This is a LOM technology, laminate object manufacture. You can make such complex, complicated, big parts you can make using the sheet lamination method. So what happens here, you have a roll of sheet which will pulled by another roller. And once this is one layer comes, for example, the first layer comes here, the heated roller will move on the sheet and it is pressed against the bed. And the laser beam will move in the XY direction according to the cross section, and you see this a carbon dioxide will move, and the remaining portion it will hatch, so that this portion will act as support structure for this part, and this entire thing will be attached to the build platform. And once this pulls, this sheet will be, it will become an empty one in the sheet. So this is attached to the build platform, and then next sheet will come over. When the next sheet is coming, this platform will go down by the layer thickness, and this roller will move there. The roller will push this roller will pull this sheet. The sheet will move forward, and again the laser beam will move in the xy direction according to the cross section. In this case, you are building a what you call a cylinder object. So remaining this hatched portion you can simply remove after your entire part is built. So until the part is built, this remaining hatched portion will act as support structure. So why you are hatching it? So that you can easily remove with the help of a small knife, etc. You can easily remove that hatched portion, right? This is how this sheet lamination method works here. Similarly, now powder bed fusion technology. This is a very revolutionary technology that was brought by Carl Deckard in 1989. He got its patent. So where you take a powder in the form of fine, it's 60 micron size like a powder, and you expose it to high energy light like laser beam, and which fuses the selective regions of the powder bed. So that's why it's called powder bed fusion machines technology. And you can use thermoplastic materials, broad range of metals, etc. So earlier it was first used only for polymers, but now you are using metals also. So you got melting technology there, selective laser melting or the direct metal laser sintering technology also came into picture now. So now this powder bed fusion, you have both polymer based and as well as both the metal based technology, right? You can see in powder bed fusion you have powder, and that powder will be spread by a roller onto this platform. This once the one side your cartridge where it will feed the powder, this roller will spread on it on that one on the build platform first layer, and the laser beam will move according to the cross section. The powder gets exposed to it and it becomes hardened, and then next the roller is on the right side, so you have other cartridge from here, it will push another material. The roller will move to the left side, spread the left side this powder. Again laser beam will move in the xy direction. Like this one layer gets attached to other layer, the platform will be always moving down z direction, and the laser will move in the xy direction. So only here is the powder is in the form of small 60 microns or like that size. So sintering happens means the two between the two powder particles, they attach. But in sintering, what happens is the amount of there will be still some gap between the two powders. So you have the chance of porosity. In the case of SLS, you can have a dense particles up to dense parts components up to 60-70%. In DMLS, you can have up to 70-80%. But in SLM, you can go for 99.9%. You have solid components because the porosity comes down because you are entirely melting the entire powder particle. That is the reason. That's how they are having higher strength. They are now as good as the conventional forge. Still, strength wise, they are less than the conventional forged part because conventional forged part the density is 100%. Where in the case of this thing, still there is some kind of porosity. So let us see how the SLS functions. Okay. Let us see the DMLS. Both are same. Only in SLS you are using a what you call the polymer powder, but in the case of SLM you are using a metal powder. In the earlier case SLS you are sintering it, whereas in the case of this SLM you are melting it, and the layer will build one layer or another layer. The platform will come down and the laser will move in the x direction. In the case of SLS, the laser beam used is a carbon dioxide laser, whereas in the case of this in the case of SLS, in the case of SLS you are using laser. In the case of SLM, you are using a fiber laser, high in because you are naturally using a metal, no metal powder, so it is having high intensity light you have to send, so high strength light you have to send. So the machine cost also SLS is lesser than the SLM machine. But if you see the process, it is more or less similar. Please let us watch this SLM video. So you can use a multiple lasers also you can use at the same time. And other thing you have to take care here is you should have inert atmosphere here. So you are using a non-reactive metal like stainless aluminum, you will use a nitrogen gas here. But whereas if you are using a reactive metal like titanium, you use a argon atmosphere. So that this otherwise what happens if there is no inert gas, it will start reacting with the outside atmosphere and its lumps of powder will start forming. So you have to use inert gas atmosphere inside the build area. So you require a nitrogen generator or you require a argon cylinder you require, and also you require a there is a lot of additional equipment you have. You should have a powder sieving machine, and you should have a dehumidifier from removing moisture. So that's why running this SLS is a costly affair. And definitely it has got its own advantage, higher surface finish, and you can have good strength parts, everything. So high like aviation industry or medical industry, they use this SLM technology a lot. This one. See such a complex shape you can produce such complex shape you can produce like a this kind of turbine blade with propeller you can produce very easily using this technology. Conventionally very difficult. You can also confirm a channel cooling channels also you can produce in your machine components, etc., which are very difficult to produce using the conventional method of manufacturing. So that's how SLM is very popular. SLM or DMLs are very popular with aerospace industry, or where you require high-end applications. In especially medical industry also they are using a lot. See the shape of this plate, how complex it is. So we have this machine with us in our center. Professor Sriram Ganesh is going to present a live demo of how part is built using this SLM technology in his lecture. Sir, is the video clearly visible or you have any clarity issue?
The video
Hello?
is very clear, sir.
Okay, because I am having a message that because of your poor internet, I am getting a message like this. That's why
No,
I
no,
got it
no,
out.
no, no,
No,
no, sir,
no,
no.
no. Right. Okay.
Please
Probably I
continue.
am not making the audience to sleep.
No, sir, not.
I'll give 1 minute time. You can ask questions because I am continuously delivering the lecture. I don't know how many of you are listening to it. In between, you have some questions they can ask.
Yes,
It is an online mode. Online mode, I don't see their faces directly, so they have questions you can ask in between for 1 2 minutes. Otherwise, I'll proceed for the next present slide.
yes,
Any questions in the chat box?
participants, you can ask questions.
Just 1 or 2 questions because we have to continue our lecture. So just to stop monotonously giving my lecture, just I was
Sir, there
see
is
how
one
many of
question.
you are live.
There is one question from Mr. Nitin. Uh,
What is
powders,
that question?
powders available for different applications. I think he want to ask that what are the various powders available for different applications in SLM.
SLM, yeah, we have stainless steel alloys, we have aluminum, we have nickel, cobalt, chromium, we have titanium, and copper-based powder is also available. I'll show you at the end the capability matrix of our center, where you can
Sure,
see a lot of materials in SLM
sure,
technology.
sir, sure.
Right. Still, sir.
Is there any questions? Is there any questions? Mr. Prashant is telling, sir, reuse of powder has better quality or not, or process. I
Yeah,
think you
we
want to
as
ask
soon
that. I think you want to ask that whether we can use the reuse of the powder for same quality as we use for the before use of the powder. That means what is the difference between
Original powder, right?
original powder or the use of the powder, or we have
So
to
thing
either
is
process
we
or not. I think we have to process
the
that as powder or not, or we
So
can use
what we are
directly.
doing is after the part is entirely built, no, that powder with the part and powder will be sieved. We have powder sieving machine. Professor Sri Venkatesh is going to show the entire thing process in his lecture. So once we sieve it now, the component will come out and the unused powder in that again processing will done. So remove filtering and impure particles and all that moisture, everything will remove. And that powder will be mixed with the new powder 60-40 proportion like that, and you can reuse it without losing any its chemical characteristics. That part is done during that post processing after when you remove the part.
Okay. So
Okay, sir.
is there any
Shall I
questions?
proceed? I will.
Ye- yes, sir. You can proceed, sir. No questions so far.
Right.
Please
So
continue.
direct energy deposition is another technology where you use as I said, powder particles will come through two nozzles and then it is hit by directly a laser beam, high intensity laser beam. So you get the part build up here. So here the advantage here is this is called lens, laser engineered net shaping. You can build functionally graded material. That means, for example, one side of the part you require one property, other side you require other property. That you can achieve both in using a lens technology, and it is costlier than the SLM technology, and is maintenance cost is also very high. This is there in our DMRL. They have this lens technology with them. So let us see they use a cadmium fiber laser they use. Here also we use a fiber laser. They use titanium, stainless steel, inconel, etc. Full dense parts with good metallurgical properties you can obtain in this case, especially suitable for aerospace and other defense application. Even in medical, you are seeing in the right side of my screen a hip implant like that you can make using this technology. So this is what I am with the video you will understand. Direct image. See, the powder comes from two nozzles. So once the powder reaches this point, you have high intensity light hitting the powder. It gets melted. See how it is. Again, the generator you are seeing on this side. So what are the materials used? Plastic, thermoplastic, metal, ceramic metal. Now you are getting bioprinters also where you can make tissue cells, etc. That's in future you are going to see bioprinted organs also come into picture another 10 years. You have artificial kidney, artificial liver, etc. may be coming up in future also, right? So this is what you have here. metal materials, tool, steel, stainless steel, commercially pure titanium, titanium alloys, aluminum, nickel-based alloys, cobalt, chromium, copper-based, gold, silver also you can use. These are the broad range of metal materials you can use. And material versus technologies, you can see metal extrusion, you use polymer. Now you are getting extrusion metal also. Metal based FDM technology is also now there. It's a FDM technology that is used now. And you have a composites also, you are using metal jetting, and binder you are having in metal extrusion also, you are getting composites, metals, and graded hybrids, etc. You are able to use these technologies, right? And if you compare all these technologies, if you see metal extrusion very next, that's why FDM is now popular everywhere. It is seen in small schools to home, everywhere they are using 10, 15, 20,000. You can build your own FDM machine for household purpose. It's a multi-material printing, limited part resolution, but surface finish is not good as other technologies. Powder bed fusion, you have high surface finish, full dense parts, but cost of running is very high. And similarly, VAT photopolymerization, high building speed, cost is higher than a metal extrusion but lesser than the powder bed fusion technology. But it is also costly when compared with FDM. Metal jetting, multi-metal you can print, high surface finish but low strength of the metal you have. Binder jetting, you have full colored objects you can produce, requires infiltration during post-processing, wide metal selection. High porosity is a problem with the binder jetting. In sheet lamination, you have high surface finish, low material machine processing cost, but decubbing issues are there. So that is not attaching one to thing, some kinds of gap you get here. And direct energy deposition process, repairs or damaged on parts require post processing of a machine, etc. Right. So with this, these are the fundamentals of 3D printing that I want to talk to you. So still there are a lot of things which will take one semester to talk. But let us go to the innovative, interesting part of the innovative application of 3D printing. As I said, NASA using this technology for sending the rover to Mars, in which 70 FDM parts are printed using 3D. Using 70 parts are printed using FDM technology, FDM 3D print technology. Why I think is the challenge here is when you send this rover to Mars, you are lifting it from Earth to Mars, which will take 1 year to travel, and you have to have such weight you have to lift, and weight should be uh, made less so that you should have a component with less weight but able to withstand harsh atmospheric conditions of Mars. So without compromising on strength, you should have such kind of parts. So they used FDM technology for making such type of components. They already made this rover. It comes under desert rats research and technology studies, and testing in Arizona deserts. This kind or this kind of rover already they made it. This video I am going to show is how NASA is using this technology for making its next rover where it will taking humans to the Mars.
We retired the space shuttle this past year after 30 years of excellent service to our nation, and its time had come. It had been a fantastic program. It had done amazing things. But now NASA is ready to really take the next step, which is a more continued presence in outer space beyond low Earth orbit. Our ultimate goal is to get humans to Mars. When we started this project, we thought we were really clever thinkers. We had some technology we wanted to explore that involved multiple wheels and the ability to turn in any direction. We thought, well, what if we build a cabin and have the crew go out for multiple days? That's really where this small pressurized rover concept has really evolved into the space exploration vehicle.
So the SUV will hold 2 astronauts. They basically live in this module, in this rover. It's your own personal SUV in space. You always want it to be as light as possible. You also want it to be strong enough that it's got your safety factors, that nobody's going to get hurt. You're going at several thousand miles per hour just to escape the Earth's atmosphere. So you've got to be able to handle all these vibrations and all these different things just to be able to get out into space. And the vehicle can't be damaged. There's probably around 60 to 80 parts on this particular
So these are
rover.
the parts which are made using FDM technology.
For a lot of different reasons. You know, sometimes traditional manufacturing methods don't really work for some parts that you want to build, where you can do it with additive manufacturing, and it's really simple. really takes no effort for what would otherwise be a very complex process. Whether it be ducting that's got flame retardant characteristics and properties to it to help keep people safe, or different fixtures and different parts. There's absolutely a place for additive manufacturing. There's a lot of things that you don't see that really get to go on is the design verification and the functionality checks of parts before we send them to be manufactured. If the final product is not going to be an
Even the
additive manufacturing
electronics, this
plastic
casing
part, we will do it in a
monitors
rapid
everything
prototype fashion where you'll get
that
it back in maybe an
used
hour,
for
day.
putting
What
electronic
that allows us to
components
do
inside.
is be able to
Everything
check
is
our
done
design
using
and make
this
sure that
FDM
everything's
technology.
going to work the way we think it is. Sometimes vendor components are a little bit different than what you anticipated, what the drawings say. So you're able to functionally build up this assembly and check it to say, hey, this is what we want, or hey,
Now
we need
it
to
is
make some
used in 3D.
tweaks.
Even in India also, in our Tejas aircraft, lightweight aircraft, as Dr. U. Chandrasekhan was heading the GTR at that time, they use this FDM technology to make Kaveri engine prototype. They used to produce 2,500 parts using FDM printing process technology. And what they found is conventional fabrication is costing 60,000 and time taken is 12 months, whereas in direct digital manufacturing using FDM, they produce it within $20,000 and 1.5 months. So you are saving cost by 66% and time by 87.5%. This is how the Kaveri engine, we use the FDM technology, 3D prototype used it. This as per the statistics given by Dr. U. Chandrasekhar sir, is the expert, one of the expert in 3D printing in India, who started initially this 3D printing application in aerospace and other defense applications. So even the Curiosity rover for Mars is completely built using the 3D print technology. You can see the parts, everything, part FDM 3D printer. They made all the prototype model of that rover, everything, and they produced it, and they finally used Ultimaker from producing this component. So in fact, in our college, for a part of my MTech students, we produce this small CubeSat satellite model, a prototype model using the entire 3D printer. Even the nuts, bolts, etc. are produced using 3D print technology. Basically, a nano satellite is a type of miniaturized satellite for space research. Its mass ranges from 1 to 10 kilograms. And since it is in the form of a cube, it is also called CubeSat. The maximum mass of one CubeSat is 1.33 kg. It is modular. You can add to another CubeSat, become 2U CubeSat or 3U CubeSat. So it is basically we have taken this design from the California Polytechnic University. We have taken this dimensions, everything. Then we model that. There are different structures in which you can model. We have selected the pumpkin structure because less variety of parts makes design simple. It can be easily expanded from 1.8 to 1.5. Less manufacturing time of cost and easy to assemble disassemble. So that's why we selected this pumpkin structure. And then we model the entire thing using the SolidWorks and other software model. You can see this green color in which they put all the printed circuit boards for doing all the research, etc., for doing this communication, everything. So this isometric view of CubeSat 3D model without side solar panels. This is what we have done here. So top solar panels we have put. So from which it draws the energy from the sun and sends to these circuits. They perform a specific purpose, right? So we use Ultimaker for making this entire structure. And I got the chance to myself and my student, we presented in Sriharikota in 2016 national conference, and it was a very successful one. And you can say this type of works you can do in other colleges also. Most of the students are doing this work in CubeSat other applications. Let us come to the sports field. You can see variety of application of this additive manufacturing in sports field. If you want to do some kind of yes, Mr. Nitin, I'll answer your question at the end of this session, definitely. And DDM is direct digital manufacturing, is another name now used for 3D printing. You can use it for this helmet of that cricket, or you can make this bales, you can make the stumps and bales, you can as well as make the golf sticks also you can make using 3D print technology. These stumps which you are seeing nowadays in all formats of cricket, starting from T20 to Test match to One Day International, everywhere you are using this 3D print. This is called zinc wicket system. These are printed by Bront Eckermann, an Australian mechanical engineer who developed these stumps. In single step, they made this. Inside this, you have electronics LCD display. The advantage of this zinc wicket system is that the umpire can make a correct decision whether it's run out or stumped or etc. And also for the audience, also what happens when you see in the stadium is bales will fly over, and definitely in a day and night match this will appear like a Diwali cracker. It's the aesthetic sense that is being attracting the customer. This is how in this first wicket system was introduced in 2015 domestic cricket of Australia. Then in 2015 World Cup also they introduced this one. Now it became a default in most of the crickets. That's why they are very costly. So the winning team captain is not allowed to take the stumps. Earlier there is a tradition that whoever wins the game they take the stumps away. But now the earlier stumps are dead stumps. There is no liveliness. But here there is a liveliness. There is a lot of glow in the field, right? So that's what happens in this match, because cricket is no longer a gentleman game. It's full of a lot of money involved here. So any small mistake involved in making a decision will have a lot of impact. So that's where empire should want to be more careful. So this is how they thought of developing such type of wicket system, zinc wicket system. It is called, it is developed by Braun Teckerman, Australian mechanical industrial engineer. So you can start thinking about why. That's what I'm telling. 3D printing, diversified application. You should think about the application. Start using 3D printing. You can develop your own 3D printer. You can develop your own material. You can set up your own process panel. That's how the research can happen. So think about an application, work on that. Reverse, you do it, right? So similarly, Reebok developed its own shoes called Reebok Liquid Speed, and this shoes is designed for distance running, cardio workouts, and comfort. The technology is liquid drawing, pneumatic material extrusion via robotic arm. So you can see this how this Reebok liquid shoes is made, liquid speed shoes.
Footwear manufacturing really hasn't changed over the last 30 years. In fact, if you walked into a factory 30 years ago or you walked
Earlier
into
the
one
shoes are
next
made
week that was
using
making
mold
footwear,
making.
you'd see essentially the same thing. Every shoe from every brand on the market is created using molds. Shoes are expensive because molds are expensive. What if we created a new process to make shoes without molds? We'd get a lot faster and we'd change what we make, how we make it, where we make it, and who we make it with. This is the Liquid Factory Lab. It's unlike any other shoe lab anywhere. We're using state-of-the-art manufacturing software and machinery to build a system that literally draws shoes in 3 dimensions. We had to give our machine something to draw with. That's the liquid part of Liquid Factory, a special high-rebound liquid material made for Reebok by BASF. The bottom of your shoe is called the outsole. It provides traction and durability and hasn't been updated in 30 years. We decided to innovate the outsole with the Liquid Factory process. We had the machines draw in layers, and this allows us to build walls of high rebound material, layer by layer, to create a framework for the shoe. We fill that frame in with a high energy material to create the first ever energy return outsole. It has twice the energy return of a typical rubber outsole. We program the machine to keep drawing and add wings to either side. The wings stretch and mold themselves around your foot as you lace up, giving you a fit like no other shoe. Because it's physically connected to the outsole, you feel the ground in 3 dimensions. While the Liquid Factory process is completely different, the Liquid Speed shoe is tested exactly the same as every other product we make. Liquid Factory is not just about a new way of making things, it's about a new speed of making things. With Liquid Factory, there are no molds. We can change product almost instantly. But Liquid Speed is just the first step. This is the beginning of a broad new menu of product development. This is Liquid Factory, and this is Reebok.
So companies like Adidas, Nike, Under Armour, New Balance, Reebok, they are all using this technology a lot. Like Adidas uses direct laser sintering, carbon, polyurethane material to use and make midsoles, uppers and other parts, cleats, heels and outsoles. Whereas Nike uses SLS, UOS, SLS 3D printing system. They use thermoplastic polyurethane powder and they produce midsoles and other things like uppers and other components of the shoes. Under Armour also does. New Balance uses SLA. Formlabs they use SLA for making rubber durable resins, etc. They use for parts like cleats, heels, etc. Whereas Reebok develops its own process, material extrusion, liquid drawing process, and they use polyurethane, other thermoplastic for making uppers, outsoles, midsoles, etc. These are the various shoe manufacturing industry using AM technology. Now let us come to our most interesting part. Most of us like movies, so let us see how the movie industry is evolving and changing itself from the earlier case. For example, in olden days, if you see Telugu movies, you used to see a director called Vitlacharya. I don't know your age group. What is the age group of this audience? Average age group. Most of you might be faculty of young age or students, but in our earlier days, in our childhood and earlier younger days, we used to see black and white films where you see a lot of what you call in Telugu you call Janapada Chitralu, we call it as. So in that we used to have a king, folk films used to have kings, everything. So in that movie, there used to be a fight between the king and the demon, and lot of things used to come out of that in that movie. Lot of those things are controlled by mechanical elements, and that mechanical elements are using lever mechanisms, etc. That at that time Vitlacharya was a famous that used to. It is like Rajamouli at present in Telugu film. At that time used to have Vitlacharya creating such unimaginable things on the screen. So nowadays also people are using this VFX effect everything for making the audience to come to the theater and see it, because once you get so many online platforms to watch a movie, why you want to go to a theater and see it? You want to go to theater and see only if you want to have a big screen experience with a lot of no unimaginable things happening on the screen which you never think regularly, right? So such big things you can see watch only in a theater, you'll have full experience of it. So in movie making also they are using 3D printing a lot in lot of hit Hollywood movies like Lord of Rings, the battle scene, or you can see the weapons that they are using in that field, or the unique type of weapon they developed, or you can see in the movie like Iron Man 1, 2, 3, that suit of the Iron Man, or the Robocop, or you can see the movie like Jurassic Park, the big dinosaurs, or all those great blockbuster movies. What you're seeing, they are all using this 3D print technology a lot in Hollywood movies, and now slowly in Telugu film industry also some people are started using this tech because 3D printing is costlier, but now because the budget is going up, the filmmaking budget, so they are taking this technology, they're adopting this technology. In fact, they are adopting, and you see in Hollywood, there's a studio called Legacy Studio, which uses this technology a lot. There are a lot of engineers working in the studio. If you go to that and see, it appears like a kind of manufacturing plant, like industry. It works. It's not. It doesn't appear like you're working in some film. It appears like you're working in some industry. So many engineers are working and making the screenplay so beautiful that when you see on the screen, it appears very realistic, right? So they're using this technology. So let us see how that is used in this technology. What you are seeing on the screen are famous movies like Avatar, or nowadays you are seeing another movie is coming called Colony. Colony, another movie, very famous Hollywood movie. So generally try to watch those movies. So you find how the technology adopted in those movies. You learn as an engineer, you learn how you can adopt technology for making film making such a wonderful, because most of us like movies. So you are well versatile in using this 3D print technology. Tomorrow you may be required in a very big budget movie where you can get a lot of money. Right. So that's why I'm telling 3D printing is a very important potential thrust area. That's why most of the government like our central government encourages in 3D printing. Lot of programs are conducted in 3D printing and to educate the people. This is the next area where you will get more jobs, etc. So try to take knowledge, try to gain knowledge in it, try to prepare yourself, gear yourself for this new technology which is coming up a lot, and in future most of the manufacturing will be 3D printing manufacturing one. It's not that conventional man will not be there, but this will become a major component of manufacturing process. You have to adopt. It's like earlier our entire mechanical things are run by mechanical elements. Now you are running an automobile with the help of a computer, with electronics, sensors, everything. So it's a combination of all the different technologies, right? So do equip with this technology. So this is what I want to tell is, you see all these movies, they're using this technology. Let us see with a video how this technology adopted by this Legacy Studio in making such wonderful movies.
Legacy Effects creates practical effects for hundreds of movies and commercials annually, from creature design to prosthetic makeup to animatronics.
This is called new field called animatronics. Animals.
Our approach incorporates the
See,
latest
FDM printer is used in this technology. You are good in CAD, you can work in this modeling field. See, an engineer working in a film industry, Hollywood movie industry is working here. So you are very good in CAD. Don't think I will work in some automobile or some other. You open up your mind. You can work anywhere with that knowledge to such creative industry also you can work there. You get jobs there also.
The founding partners at Legacy Effects supervised projects at Stan Winston Studios for 25 years. It was there nearly a decade ago that 3D printing really started to emerge in the special effects workflow.
Back at Stan Winston's studio, the design department was
Yeah, how many
basically
design
working
people
on
are
more
there?
visual effects rather
Very
than
interesting field.
practical effects.
You have good
we
knowledge.
started playing
It's
with
very
different
creative thing, challenging
technologies to
thing. You
work
can
hand
work
in
there.
hand more with
It's
the
very
traditional
interesting. No,
physical
no boring
effects
at
that
all.
Stan Winston was
You will
producing.
have good lot of job
Fabrication
satisfaction.
department, the mechanical
See how many
department, the
elements they are
electronics
making.
department, mold making department, and the model shop. We needed to
It's
bring
mold
design in
making,
to contribute.
3D printing.
Around 2006, Alan Scott was approached to do all the miniature.
So in this particular horror movie, this movie, what happens is they're creating all this battlefield by scanning the entire faces of the actors. Accordingly, they are producing small objects called figurines, like the same actor with a different suit he wears, how it looks. And these emotions they are capturing with high definition camera and using VFX effect they are making to look realistic, the battlefield.
For this Halo diorama.
Halo diorama.
Halo diorama was extremely ambitious. We ended up creating 700 figurines, about 7 inches tall, that depicted a massive battle. A huge motion control camera went over a stage that was 70 feet long by 30 feet wide. You had vignettes and scenarios, explosions, shots of agony, and people getting killed, hundreds of different poses. That meant that we had to create things really, really quickly.
We utilized the artists that were still in that design room, taking the game assets and converting them into stereolithography files that we could send to a service bureau to actually produce physical parts.
Using 3D modeling, we would grow some just to be molded. We would break them apart with arms and legs and heads, put it on a body, and get a variety of different poses out of that one part. There were some that were so specific, we scanned a whole battery of actors and different expressions, then grew their faces, and then we would populate them on different figurines.
It was a perfect testing platform because in the delivery and the amount of characters that needed to be done, traditional sculpting would never have worked just within the deadline.
This tool allowed us to do that job.
When we got into projects like Iron Man, we did a variety of maquettes through 3D printing, additive manufacturing in acrylics or whichever materials that were being offered up at the time. That was so successful, just growing those maquettes, that I ran some numbers and tried to figure out, well, maybe we could utilize this process in growing the full Iron Man. The numbers worked out, and that was kind of the first one we kicked off as a full-size piece that we did completely rapid prototype. At that time, we were the first people to do that type of work. It worked out great. We were all really excited about it. Stan was very excited about seeing this process taking the next step.
After the untimely passing of Stan Winston in 2008, we formed Legacy Effects, and we were still in the middle of Avatar. And we had been beta testing new sculpting programs and starting to think, boy, it sure would be great if we had this printer in-house.
We brought in an Object Eden 260V, which we still use to this day, almost 24/7. In the morning, I could print you a rigid part. After lunch, I could maybe switch and print you a small clear part. And then back by 5 o'clock, I could print you a rubber part, all by pushing a button and changing out materials. That's killer for this studio.
You want fluidity, yeah, and that's what this whole business is based on.
In a feature film now, you'll have 4
So this is how you can use for filmmaking industry also. Like you use this Iron Man, entire FDM technology they use for making these parts, and they coated it, it appears like a metal one. Like 0.30, another very interesting movie. They use a UK 3D printing company as a hire to 3D print aluminum night vision goggles because the original cost was $60,000. So instead of spending on that, they produce a replica of that using the 3D printing technology, right? Similarly, the Hobbit trilogy, you might have seen these movies. You see in big screen, this appears very interesting. So very, I get a lot of joy to your eyes. You feel very happy when you see such movies in big screens. Is it realistic? Is it how it appears? So you are making such different types of suits, etc. Props they are making, this weaponry they are making, which you never imagine you can produce in conventional method. They're using this 3D print technology a lot. In this movie came in different series from 2012 to 2014, different parts. They use 3D printing for this. In Guardian of the Galaxy, another very famous movie, got part 1, 2, etc. Again, they use 3D print technology that we printed several weapons that appear throughout the movie and also 3D printed certain parts of the spaceships as well as Korath and Pursuer suit. These are the characters in that movie. They have printed all of them. Similarly, Maleficent crown and costumes are made with fused filament fabrication process. This is the type of things. This is how additive manufacturing used in the movies. Coming to our food processing industry, now in pandemic, most of us don't most of us doesn't feel comfortable for going to a restaurant eat it, but you want to have such kind of food in your home itself. You can have a 3D printer which produces different shapes and with different composition nutrients you can produce using this food processing industry, right? So then basically use binder jetting method or metal jetting method, paste extrusion, inkjet or indirect mold method you use in food printing process. So this is a active participation. You can have good eating experience, cooking experience, personalized, pleasure, affordable. All these things are making food industry also to adopt 3D printing technology, right? So you can have benefits are customized nutrition, flavor, color, texture, on demand and on the go production. You can have economy at low volume production, flexibility, new type of product design you can make, novel mouth feeling experience, all of them you can make using this technology. Challenges is you should have a shape stability, replicate traditional foods and rheology. Manufacturing technology you can adopt is safety, easy to clean surface and cartridges, throughput, high throughput or large reservoir needed for. These are some of the challenges that you have to take care when you use for food processing industry. So NASA is using this 3D printed food for its Mars expedition, as I said. And these missions will take between 1 and 3 years to complete. During the time, astronauts need to eat, and NASA is looking into ways to enhance their life supporting system, including the possibility of 3D printing meals. So they are given a company, this Systems and Materials Research Corporation, to develop food 3D printers. Now, this Texas-based company has already come up with a system that prints pizza out of combination of powders containing the necessary nutrients. So you can see this how NASA is using food process in 3D printing technology for developing food for the astronauts to be sent to Mars. It's a very interesting
US
project.
space agency NASA is funding a company to develop 3D printing of foods. Advocates of 3D printing technology say delivering long-life foods from alternative ingredients could help solve the problem of feeding astronauts and ease food shortages on Earth. Manned space missions require stocks of non-perishable foods. 3D printing could be a promising solution to the problem of feeding crews. Traditionally, food sources perish easily. Proteins, vitamins, fibers, and carbohydrates can be derived from alternative nutrient sources like insects, grasses, algae, and seeds. Stored as powders, they can last for years. When combined with sugars and oils, nutritionally dense foods can be created layer by layer. NASA will provide US firm Anjan Contractor with $125,000 over 6 months to make the technology viable.
So
US
this is
space
how
agency
3D printing can be used in food industry. If you see how 3D printing additive manufacturing used in jewelry industry, it is now become very popular because you require a lot of creativity in making complex designs in jewelry making. So you can either go for investment casting or direct printing in jewelry making. Investment casting is you require to make a pattern using 3D printing, either wax pattern, etc. And you develop a mold assembly. Then you dip in a slurry and build a shell around it. Then you heat it. then that wax will melt away, and you pour the liquid gold inside this. Then you build the part and you get the finished component out. This is how indirect method of making jewelry using 3D print technology. The famous technologies that are adopted is SLA and DLP technologies are used for investment casting of materials. And this, as you can see, how this type of jewelries are made using this SLA technology. This is DLP. They use DLP technology. You can also print directly from powder. You can directly print the jewelry. The DMLS or SLM, you can directly print the, but it is very costly affair when compared with the indirect way of. Most of the industry around Hyderabad also, a lot of these big companies, they adopted this technology. They are using investment casting method for making this, right? So 3D printed jewelry by direct metal printing, very accurate and very perfect shapes you can get, but cost is also high. So these are some of the software. Rhinoceros Jewel CAD is used for developing this jewelry. And these are the advantage. You can have a customization enabled to achieve complex shapes and reduce the production time. Limitation, future size, burnout remnants, and all those things. Let us see how direct metal printing you can use jewelry making. So I am in electronic industry also. I teach electronic students also as open elective. So I have done a project with electronic students developing a horn antenna. We use SketchUp make CAD software for modeling this antenna, and we build in our FDM machine this small part of the antenna which we want to test it, and we already started coating with metal components, and we are using it for that communication purpose. We want to test how it works. So most promising technology of 3D printing used in electronic industry for printed circuit boards, etc. is aerosol jet printing technology, where you clog resistant nozzle, high density micro droplets, continuous stream, and all these things are used. And you can print the entire cell phone using 3D print technology. You can, as well as Nokia produce a concept phone called Morph, which can be used as a watch as well as a phone. You can change the shape, etc. In construction industry also, as I said, we use 3D printing for making our arts college a model. This is how we are done. We have published in a paper also. So we have first modeled our collected the entire data related to the building. In fact, we have done for our engineering college also, developed the CAD model, then converted the CAD model STL file, then slicing the STL in 3 parts, and then fabricated the components. You see our arts college building. We have modeled it using the CATIA software modeled in 3 blocks. Then we produced in 3 blocks using our FDM printer, and they are joined together, so you can produce the final component. So this is how you can do. So final component is produced here, right? So this is how 3D printing, and you can see this model. You can make this model before you actually construct the building itself, right? So this is how you can use 3D printing for civil and architecture applications. You are using now 3D printing is used even for constructing houses nowadays. You can watch this direct real houses you can make. Less than 24 hours you can build. This is what Government of India mission is also. They want to use 3D printing. Yes, India want the Government of India want to make homes for everyone. So
having strong, sturdy walls, having a door that we can close at night, it's something that we take for granted, being able to lock our door and be safe. For many of these families, for years, sometimes even a lifetime, they don't have that opportunity to have a safe shelter. So when they move into a new story community, when they move into a safe home, families' lives are transformed.
recently in India also LG made one 3D printer.
Our first product is a 3D printer that can print a house in 24 hours for half the cost. Phase one for News Story and for Icon is a proof of concept house, and the good news is we've done it. We printed the first home in the United States that's going to be permitted. And for us, this is just the beginning. The real kind of home run for us is to be able to do what we've done here in Austin, Texas, in the developing world. And we're doing that in what we call phase two, which is in El Salvador. We are going to be printing an entire village for people that don't have homes.
So 3D printing revolutionized the construction industry also, and you are solving the problems of the society. There's a major impact of any technology you should have. Societal needs are satisfied a lot because any technology should help people have a better standard of living. 3D printing is helping in, you know, seen directly how it is helping in improving their lives, etc., the standard of life. And next tomorrow I'm going to present on case studies how 3D printing can be used for biomedical. Even in interior decoration also now they are using it. You went to a big mall, etc., you see such kind of fascinating thing. You can produce those things using a 3D printing technology, right? So in home also you can make like such props coming out from the wall, a horse like these things, and these are the angles of projections which are coming out from the wall. So this type of things you can make. And home decoration is now another area for where a lot of people are required in developing such type of things because people are spending money for interior decoration. So there is a lot of business out there. So you should be good. You should have creativity should be there in 3D printing. You want to work. Your creative idea should start developing a new thought and working in the direction and building the part, right? So future of AM is coming. 4D print is the theoretical concept coming up. So fourth dimension is the time or temperature or some chemical reaction which will convert a given shape to another shape. Like it's a 2D object. You put in a chemical, it will get converted into a 4D object, right? Into a 3D object. It's a 2D object converted into a 3D object because of some external stimuli from this chemical. Yeah, I thank our principal head and also Director Sira Venkatesh for encouraging me to carrying out this research. Thanks to all my students who are behind this research or what are the little bit I have put here. So thanks to all of them. Thanks to all the people who given taken from them the videos or other materials. Thanks to all of them. And I finally say open to change and break the boundaries, right? So any question answers you can ask. Thank you. This is my contact, and you can ask questions. So I end my presentation, sir. Any questions? I will stop sharing so that you can ask questions. I hope I am little bit behind my schedule, 4:40. I am unable to hear you, sir. I am unable to hear you. I am unable to hear your voice, sir. Hello? Hello? Yeah, sir. Junaid, sir, is my presentation is over. Any questions from the audience? Hello, sir.
Yes, sir.
Can
As you have said that nobody will going to sleep. We have accepted the challenge and you have won the challenge.
I did not any made you to sleep from the audience.
That's you have given a wonderful lecture, sir, and going to and covering each and every corner of the 3D printing. So
Yeah, yeah,
there are some few questions here.
yeah. Please go ahead, sir. Chat box, huh?
Yes, sir. There is one question from Nitin. Is there any usage of fuel issues if we send vehicles for exploring planets? That I think his question is, if suppose there is a shortage of fuel, if you use for long-term periods of vehicle in the planet, I
So you
think.
want to say that the fuel printing also can be done by 3D printing, even the so.
Not fuel
Is there
printing,
any
sir.
is there any usage of fuel issues if we send vehicles for
Exploring planets.
exploring planets? So based on that, no, they plan already. You are sending to Mars. You are successful. Other you send to near Jupiter. You send to other
Yes,
places.
sir.
They
Yes,
use
sir.
solar power mostly, and
Power.
they use it. And they plan optimize the usage of the power also there.
Yes, sir.
So that's how they use this.
There is another question from Jani, sir. Melting materials and then to solidification are inevitable associated with shrinkage. Different parts or each portion of slice are with varying widths. How can we ensure accuracy and precision of objects printed? I think if suppose there is a
Shrinkage
stolidized
factor.
object, shrinkage or solidifying the object.
Yeah, so when you try to take that shrinkage effect, you have to take care of that how much of each material has got its own shrinkage property. So accordingly, you have to take in the modeling itself. I told you, you have to give the proper allowances. Then accordingly, you have to design like you do in casting. How do you take the shrinkage effects in casting? You design your mold according to that shrinkage of particular metal, and then you have to make it. Here also, accordingly in the model itself, you have to take that shrinkage factor also into account and make the component.
There is another question, sir. How to print bread using 3D printer? An example of any such model available. So as you have explained about the 3D printing in food industry, so they are asking
Hmm.
the question how to print bread
B-
using 3D printer.
Bread.
Bread.
So they made chocolates and they made what you call pastries and they everything they take in the form of a powder form or in the then an extrusion you are doing a you buy an extrusion like that they will take and basically they extrude it and bread I think I have not seen bread but they use for chocolate pastry pizza and other things they produce using this technology even I don't know I never seen that bread. Bread, I think they can make, but I don't know exactly how can they make bread using.
Okay, sir. So there is another question. Additive manufacturing
Can
used
you tell
for
us which 3D modeling software?
Sir, another question. Additive manufacturing used for printing artificial or and pure gold. If so, how to use material in printer? So he's asking about the gold, sir,
Yeah,
jewelry.
gold, yeah, jewelry. They use artificial means accordingly that powder they use that artificial jewelry on they use in artificial jewelry. They generally they coat at the top layer, no, top one they coat small coating they make it. So that the coating purpose you can use, but most real jewelry, actual jewelry, you produce using 3D print technology. The artificial jewelry, if you use this technology, it becomes very costlier. Then who will buy the artificial jewelry? Artificial jewelry is meant for only no for less cost. You want to
For
invest.
less cost, yes,
It
sir.
looks like it looks like a real jewelry, but it's an artificial jewelry. You may use some coating, etc. But in real jewelry, now they are using this 3D printing.
So it's so
Can you
powerful.
tell us which?
It's
There
so
is one question I think. Can you
yes, sir.
tell us which 3D modeling softwares are used in film industry? Maya, Maya software you can use for modeling. Very famous software it is used in film industry. They are using other softwares like high-end softwares like AutoCAD Fusion or other modeling software like your in SolidWorks and all. Depends on the application, but most popular is they use high-end software like Maya graphics and other things, Rhino, etc.
Sir is asking if we print gold completely. So for that we need to powdered gold first for as a filament. So that will cost more for printing gold. He's saying, sir.
That's what I told you know. You have two
Yeah.
methods: investment casting method, other than direct minting.
Yes,
In
sir.
direct minting, you require a powder form, the gold, and that is why I said it's costly affair. That's why most of the people will go for investment casting method, where you make the pattern using any 3D print technology. Basically, the pattern is made with wax, and then they make a slurry and dip in the slurry, get the shell, and they like investment casting. They melt out that. Wax and then in that they pour liquid gold. That's how the ornaments are made.
Yes, sir. Is there any questions? Is there any questions? Is there any doubts, questions, queries so that our speaker will answer you, clear your doubts?
Anyone also can give feedback also because in Atal ACT for every session you require to upload a video on feedback also.
Feedback, sure, sir.
Anyone can give feedback also. Live you can direct. Any
Sir is
any
open. Sir is very open and concerned about the feedback also, sir. Sir is so
definitely
kind.
definitely I'll
Please,
definitely try to
please,
improve myself.
sir.
Always I
Sure,
try
sir.
to improve myself.
Yes, sir.
It's not that we are also learner. We'll also learn from the
Definitely.
audience also. That is the
Sure,
openness and academician
sure,
should be there. We are always a student. We always should learn.
sure. Definitely, sir. So that means there is no doubts from any of the participants. You have
Yeah.
cleared all the doubts before itself.
Yeah. So
So
thanks, sir.
I would like to highlight some of the points which you have said in this session, sir. You have given a wonderful lecture and you have covered. The first thing I would like to say that art college that was very nice, sir. Very nice. That
So we thought of in the centenary celebrations in Osmania University, we thought of making memento of arts college. Why to
that was
give memento other mementos? We'll give our college itself.
our college itself.
So we use 3D printing. We made a arts college, and we even made during my GAN program. I made our engineering college also. We produced 3D printed in 2019 when we conducted GAN program in March 2019. I have made our engineering college also 3D printed
That was
using
very
FDM
nice.
techniques.
That was very nice,
Mm.
sir. You have also
Mm.
covered various applications in the space, jewelry, industry, food, satellites, additive manufacturing processes, materials, extrusion machines, various machines, polyjet, binder jet machines, and you have also given a wonderful comparison. Once introduction for a student, if any person is introducing in the 3D printing field, he should know what are the various comparisons of the different technologies. So you have given a good explanation about the comparison of various additive manufacturing technologies. You have also given best example of shoes in additive manufacturing with various companies currently using like Reebok and other etc. And various applications in the entertainment also, sir, with examples of your personal examples as well as the information regarding the creating the interiors with Z Corporation. I would like to conclude this session, sir. I request once
Thank
again,
you.
I thanks once again Dr. L. Shivaramakrishna, Joint Director, CPDDAM, Associate Professor, Osmania University, Hyderabad, for giving a wonderful lecture on 3D printing and its innovative applications, sir. I once
I
again
would
thank
also
you, sir.
like to say here, I'm very proud that my students also become experts in this, especially I speakers in this Atal AICD program like Manmadachari, you might have delivered morning
Yes, sir.
biomedical modeling,
Yes,
and you
yes,
might have seen Balaji also topology automation. They are all
yes,
my students. I feel
yes.
proud about them, and they are working in 3D printing a lot. And
Sure,
even Balaji worked for some Telugu film industry, also developing the 3D printed parts. I've forgotten that. And even Manmadachari has done a very wonderful work in his PhD and MTech also, and he has I was getting patent also on that PhD work. So I would like this is the area where people can start
sure, sir.
working a lot. There is a lot of potential for the
Yes,
people to work.
sure.
If anyone wants to meet, we can come call. I think some Salman Shah Qadri is asking, sir, can we meet you at University? Yes, you can meet for research related queries, but only thing is you have to please take prior appointment, call us, and then so that we'll be busy with some other activities.
Sure, sir.
We can fix some time. But now this now because pandemic is a little bit that direct interactions we are missing. You can call initially. You can have initial discussion through a call. Then later you want can come and visit our center and see it. Thank you very much. Thank you,
Sir, I
Moinuddin sir. So
request,
tomorrow again my session is there. So
yes,
tomorrow.
sir. Tomorrow morning, sir, at 10.
Hmm.
At 10, sir. Tomorrow
Okay.
morning, we will going to meet you, sir, tomorrow on fourth day on biomedical application of 3D printing, sir. So I request once, sir, you please keep increasing the branches of yourself so that others will benefit from you, sir.
Definitely. Thank you.
Thank,
Thank you.
thank you, sir.
Thank you. Thank you. I can leave now.
Sir, yes, sir, we can leave, sir. Thanks once again, sir.
Thank you.
So I thanks once again the participants to be to have patience. Now we will going to conclude the session tomorrow at 10 o'clock. We will going to be here once again for listening the biomedical application of 3D printing session by Dr. L. Shivaramakrishna, Associate Professor and Joint Director, CPDDAM, Osmania University, Hyderabad. So if you have any queries, doubts regarding any other problems, we can discuss. Take care. Goodbye. Allah Hafiz.